Okay, so I'll just set up sort of a dummy scenario and then we'll look at setting up the real thing. So I'll just create a few cubes, or just one cube for now. And then I'll create a sphere. And I'll just delete their history, use their transformations. So if you don't see the bullet tools in your under effects, if you don't see a bullet menu set like this, you have to turn on the plugin. It might not be turned on by default. So under settings and preferences in the plugin manager, there are two things you should set up. There's the ABC bullet bundle, that's for exporting bullet caches, and then bullet bundle here. This is another Disney innovation that was used for some movie that was then ported into Maya. But it was ported in, so it wasn't really integrated into the greater Maya dynamic system. So it doesn't interact with particles, end particles. It's a thing on its own. It's used for, shattering, destruction, stuff like that, or for game development, for baking in physics. So if I select this cube and go to my bullet menu, and I'll just tear this off, I can turn this into an active rigid body. If I open up the options, I can change the collider shape type. So it's not actually the object that's going to collide, but a colliding object that is enveloped around it, or enveloped around it. And so for this, we can just change this to a box because it's a box shape anyway. And then this thing, we can turn into a passive rigid body. So it won't move, but other things can collide with it. When you do this, a passive or a static body type, it says here, you can choose the mesh shape, so the actual shape of the object itself, or you can use a hull, which is the closest thing that matches the shape. So I'll just choose mesh shape. And now, if we just play the animation, oh, I don't think I said hit OK. Line close. Yeah. Nothing. Absolutely nothing. Okay, so let's make that a rigid body. And I'm going to pass the body again. I'm going to create a sphere again. It's the simplest things. So create a passive rigid body. I'm going to change this to hull just to see. Okay, so it just has things interacting with other things. Now, this doesn't have a nucleus node because it's not in the nucleus environment. Instead, it has this thing called the bullet solver. But it's sort of similar to the nucleus node in that you can turn on a ground plane here. And so now if I play the animation, it will not hit the ground plane. Oh, God. So we can make our own ground, right? We'll just make our old friend the plane. I don't know why these things don't work half the time. They just don't. So turn this into a passive rigid body. See? Okay, perfect. So you can see how it works. It has you can make objects active or passive, and that's essentially the whole thing. So let's say we want to make a whole bunch of things. I'm going to create a new scene just to get rid of all the crud. So let's say we want to make a pile of cubes fall down. So I'll just create another cube. And I'll duplicate it. And if I do Shift D, it's going to duplicate and redo the last transformation. Okay, so we can have a whole bunch of these things. Delete history, freeze transformations, yada yada yada. And so now you can do something different here. So I can create an active, I can click create active rigid body, and they'll be created as separate active rigid bodies. Or I can instead choose a rigid set. And it creates separate rigid bodies for each of these, but just one controller. So if I open this up, there's nothing really new to do here. Apply and close. So now we should have all our polycubes, the bullet solver, and then the cube mass solved. So you can see a new object is created, and it's one object that has a piece for each of these things. And in the bullet solver, I can try and turn on the ground plane again, see if it works. And so you can see you get a pretty fast simulation. Something like this. Now, Adam was using this, and sometimes you get some problems where they never stop moving, they jitter along the ground. One way to try and solve that is this internal fixed frame rate. It's set to 60 hertz. And this is sort of mimicking the frame rate of a refresh rate of a screen. So if you're a gamer, you might know for video games you want a high refresh rate screen, so 120 or 240 hertz. So if you turn these up, it's just like adding extra solve samples. This one's working fine as is. Oh, see, it changes the nature of it because it's solving more often. So it's at 240. At 120. And go back to 60. Oh, don't play backwards. So just a couple other settings to look at here. There's this one called split impulse. And this helps if there are overlapping objects at the beginning of your simulation, because they will push each other away from each other and you'll get this kind of explosive animation. If you turn this on, it just ignores that initial push away. They'll still collide with each other after, but this helps solve that problem. You can see gravity is built in here. You can turn on use Maya fields, and then you have to apply a gravity field to have them fall, and you can apply other fields. But I have to say, I can't get this to work very well. So I've just been sticking with the built-in gravity.
If you wanted that column of cubes to fall down and kind of just stick where they fall and not interact with each other further, do you just play with stickiness, or do you turn?
So yeah, if you want to, now it's not quite as flexible as end particles are in that sense. So if I select these, it's kind of hard to find where to control all this stuff. So if I go to cube mass solved, no, that's just transform. If I go here, that's just shape node stuff. But if you look here in the bullet solver, and you'll notice I've got my shapes turned on. So if I turn on shapes in my outliner and open up the bullet solver, you see these things like cube mass initial state, and that's where you find the controls for all that stuff. It's kind of hidden. So if you look in the cube mass initial state and open rigid attributes, you can change the mass. So if I change these to 100, see if it acts differently. Who knows, maybe. You can change damping. So if you turn up damping, so let's turn this up to an almost 1 value. So it's damping their motion. Put this one back down. And then angular damping, so that would have to do with rotation, I would imagine. Turn that to 0.9. So I don't know, it's hard to tell whether that's doing anything very different. You have to cache it out and compare them. Then restitution, now this is something, if we put this, let's say we put this at 0 and see. Okay, so that's at 0. Let's put that at 1. So restitution seems to, it looks like it's a conservation sort of thing, so they lose their energy, but restitution all the way up to 1 seems not to work very well. If I go to 0.1, oops, 0.1, see. I think the default is 0.5. Then you do have collision attributes where you can change the box shape, you can change the initial conditions, but you really don't have stickiness and things like you do with particles. You can glue the shapes together. So this is what you would do if you had an object that you shattered into pieces and then you wanted those pieces to stick together. You can turn on glue shapes, and then the glue breaking threshold is here. So then if something banged into them, that's what would cause them to shatter and fall. This is this initially sleeping is a way for it to not react to just gravity pulling them down. So they're non-dynamic until a force acts on them. So you can turn on initially sleeping. You can also give them some initial velocity, so they start moving at the beginning. So if I just turn off gravity here, just set this to 0, go back and play. And then if I create a sphere, let's see if this actually works. And move it up here, in line with this thing. And delete history, increase transformations, and turn this into an active rigid body. Just make sure it's set to sphere. So for this thing, looking for here. Sorry, you can give it an initial impulse. So I wanted to move in Z. So you can give it either an initial velocity, so let's try that, of 10 in Z. See what that does. So you can collide with them that way. So that's how you can animate active rigid bodies. You can give them some force, and I can turn its mass up to give it more strength. So you don't have all the control that you have with particles and things like that, but it's a good way to make objects interact with each other in sort of a dynamic way.
If you wanted the opposite, I'm sorry.
Mm-hmm.
Actually raised your hand.
What?
Did somebody else raise their hand?
I don't know. I wasn't looking.
No, if you wanted the opposite of that happening, like particles in a chaotic state and then coalescing to form something organized, do you just like animate that backwards?
Well, you probably simulate it forwards, and then you can create a cache from it. So I'm not going to do this, but where is it? So you can export selection to Alembic, and so that's just making a cache, and it just records the positions of everything, and then you can bring it back into Maya and just reverse it. So you can do it that way. Yeah?
I actually found, now that I'm looking at my scene more closely, that when the polygons fall to the ground, they're like, some of them are deformed. Is there something that...
Oh, really?
Yeah.
Oh.
Is it, when you create an active rigid body, isn't that different than a soft body then?
Yeah, so they shouldn't deform at all. They should maintain their shape. It might be a sampling thing, I don't know. But a rigid body, yeah, should always keep its shape.
It's like some of them are okay and some of them are stretched, obviously.
I don't know. That I don't know. I have to look. Okay, so let's just look at the final thing. setting up a bunch of pills falling. So I'm just going to open up a scene. So this has been solved already, so it's going to take a second to open up. You can also do some of this with N-cloth too. If you make an N-cloth very non-deformable, it will act like a rigid body as well, and then it can interact with particles and things like that. So there is a way to do it, but this has functionality to do a mass of things at once, whereas N-cloth, it's difficult to do that way. Let's see if it's actually going to open. I think it's going to work. That's why I'm waiting. Something's happening. Oh, it's spinning again. Oh. Curse you, Maya. It's funny, I was working on this over the weekend and it never crashed once. I don't know why here it always does that. So let me just open up I just wanted to show you the finished product, but maybe that's not going to work. So let me just open a scene. I'm going to try one more time. See if we can open up from a fresh scene. Does anybody else have anything in their shots that could use something like this? Rigid bodies? There's the pills, there are the hexagons. Guess not. Okay, it's giving up. One. I'm going to count 7. 1, 2, 3, 4, 5, 7.
The reason I was asking about the columns of cubes actually was
Mhm.
the other thing I was thinking about besides making the volume out of the formula was having like data rain like come in the form of like 3D pixels and build up the Gaussian curve like that, but then I'd have to stick in place.
So you could do that. You might want to do that even with particles. Like, let's say you had like strips of geometry that were in the range. Like if you had like a bell curve sort of thing, and you had strips of polygons going up like this, and then you had a polygon or a particle system that was goal weighted to those things, so that they would stick there, and then you could release the goal weight because you can get them just to go there, and then put a field on them and have them spread out, and then again play it in reverse and have them come back there. So you have a piece of geometry that particles are stuck to, right? And then you can introduce a field into the system. You can actually animate a turbulence field going over them and send them flying off. Then you could cache that and play it in reverse, and they would be sort of coming back to a position like that. Okay, this is a slightly different version. Let's see if this works. I don't know why this is happening. I think I must be running out of disk space recording all this stuff. Okay, one more time. Quit Maya. I'll start from the super simple version. There we go. So, Pills and Donuts, my memoir. Okay, so I just made a piece of geometry here that could act like my capsule, and before I duplicate it and solve it, because I don't think this is solved yet. No, I'm just going to delete my bullet solver. I'm going to select this, and I'll just make it a little more capsule-y. I'll just extrude this. Okay, so just make something like this. So it looks like a little capsule. And then I'm going to shade it before I do anything else. And because I'm going to make instances of it, I want them all to have the same shader. So I'll just create a new Mila material and open up the hypershade. And I just want to have it two colors, so I'll put a ramp on the color channel here. So just map a ramp, 2D textures, a ramp. Now I made this out of a, I forget how I made this, it was just a sphere, I think. No, it was a cylinder with rounded ends. But if I open this in the UV texture editor, I just want to see if it fits in between here. It does. So if I grab my ramp, I can just adjust this to get the colors to meet in the middle. Oops. Change it to red or something. Okay, so there I got my capsule. So I want to make a bunch of these things. So I'm just going to actually shrink this down a little bit, make it a bit smaller, freeze its transformations and delete its history, and just duplicate a bunch. So I'm just going to duplicate these and then rotate them 180 degrees. Whoa, not translate, but rotate. And then if I hit Shift-D, it'll flip them back and forth. So I got a bunch of these. I'm just ignoring the fact that my screen keeps blacking out every time I select anything. Maya. So now I've got a bunch of these things, and I'm going to make a rigid set from them. I'm going to save my scene first and go to FX and Bullet and create a rigid set. Just make sure. So now if I play, let's see. Okay. So they fall. But now I need to have a floor for them to fall into. So in the bullet solver, hopefully, I can turn on the ground plane, see if that works. Okay. So the first thing I want to look at is how they're interacting with each other. Let me hide this obfuscating donut. I'm just going to delete it, actually. make a new one. So you see they're overlapping like this. That's because we have the original objects and then the solved pills. So we've got the bullet solver and the solved pill. So we can hide one of these. So we just see one. And then remember, if we look in the shape node of the bullet solver, we can look at the pills class initial state and their collision attributes. So this is set to box. So these aren't box shapes, so we want to change this to hull. You'd think capsule would work because they are capsules, but it makes actually slightly too big of a shape. So we can try hull instead. And try this again. So there they act a little bit better. So then there's a question earlier about how do you constrain these things to stay in a small spot. The best way I could figure is actually to make an invisible collision object. So that's what the donut's there for. So if we create a torus or something, so this is just, you could create something that made a better shape. If I create a torus like this, and I might want to change the radius a bit. Zoom out. And turn this into a passive collider. Freeze transformations. Bullet. Passive rigid body. So it falls right on top of them, right? Pills on donuts. If we look at the initial state for this, it's set to hull. We can change this to static mesh, or to mesh, sorry. Let's see if that works. Actually, I thought hull would work. And then they all fit in there. So let's say this is good. It's not that good because it's going to be kind of shaped like the inside of a torus. But let's say we're happy with it. If we render this, let's see what we get. Nothing with my software. Nothing with this. So let's unhide our pills solved. And then we get our little pile of pills there. So how can we preserve it if we just want to model it in this shape? We could make a cache and all that sort of stuff, but actually the easiest thing to do is just to select the solved object and duplicate it. And then just grab it, and then it will just maintain that shape. And it's broken its connection to the solver. Now if we render this, it should just render. Yeah, so we can render the pills out like that. So this is it's actually kind of an easy way to model something like this if you want to make a pile of things. Rather than to try and place them here, you'll get something a little more natural than this. And of course, if you needed different types of pills or whatever, you just include those models in your initial bundle of pills. And you might want to do separate shapes for those, because if you have tablets that are more disc-shaped, you might want to change the way they solve than the capsules. So you could have different rigid sets that will all interact with each other and with the passive colliders. So, that was a lot of stuff. Any questions about any of that stuff? No? Okay. So we've gone over briefly over different classes, n-hair, n-particles, n-cloth. Now this bullet system, the only other weird system we haven't talked about in Maya is XGen. There are things like fur, but we don't talk about fur because it doesn't work. It's an old implementation in Maya, but it's been replaced by XGen. So we'll look at that a little later on. It's got a really strange implementation that doesn't interact with any of the other dynamics. It's not a dynamic system, but it doesn't interact with dynamics, and the way you execute it is sort of strange. But again, it's one of those bundles that was shoehorned into Maya, but it is quite useful if you can get it to work. Okay, so I've exhausted my supply for the day. I've got an hour left, so I'm happy just to hang around and help people with different stuff. Okay? Great. Yeah? Okay.